All right, next problem is this. Now this is the limit as x approaches -1 of x plus 1 over this. It's a complex fraction. A complex fraction because you have a fraction within a fraction, right here and right here. So you would plug in -1 to see what happens. So when I plug in -1 here, I get 0 on the top. Check it on the bottom, you get 1/2 plus a -1/2, which is 0, 0 on the bottom. So this is another example of 0 over 0. This, however, is a complex fraction. So it's not going to be solved by factoring, it's going to be solved by simplifying. You will simplify this complex fraction, and I guarantee you this. See this x minus 1 here? Think this. Since we got 0 over 0, think this. And x plus 1 will cancel. Happens all the time. That's how you're going to tell if you're doing this right. It's like a built-in check. So the fact that we're approaching -1 and x plus 1, because that would make it 0, will have to cancel out. So to simplify this complex fraction, there's a couple of ways. The easiest way is to look at the denominators. This top part, the numerator, has no denominator. The bottom part has two fractions with two denominators, 2 and x plus 3. So you multiply the entire fraction, top and bottom, by the common denominator of 2 times x plus 3. So now on the top, you're just multiplying. So no need to distribute, just keep it as x plus 1 times 2 times x plus 3. So it would look like this. 2 times x plus 3 times x plus 1. The bottom, you're distributing this. You can write your answer right here. You don't have to show this next step, but I want to make sure everybody sees what's actually being done. Distribute this to this fraction and then this fraction. So it would turn out to be something like this. 1 times 2 times x plus 3 over x plus 3 That looks horrible. Sorry, I don't want it to look bad. So that was this distributed here. Then plus this distributed here would be x times 2 times x plus 3, or 2x times x plus 3. So notice that this x plus 3 is going to cancel with this x plus 3, and this 2 is going to cancel with this 2. And that's what I was saying. You can see that you can do all this in your head if you think you're capable of doing it. It's not that hard. You can go right to this step. Two plus x times x plus 3. Okay. Now there's two things I want to point out here. Number one is my notation is horrible. I even told you not to do it like this. See that equal sign? This limit does not equal these functions. That doesn't make any sense. So if I want to make sure that I'm consistent, all these limits are the same. Now, one more thing. where do you go from here? For the most part, if something is made up of factors, never unfactor it. And you know they're factors if it's all multiplication. So if you look at the top, 2 times x plus 3 times x plus 1. Those are all factors. You want to leave them. The bottom, you have 2 and then plus. These are not factors. So now you want to multiply the bottom out. You want to simplify it. And again, let's go back to here. And x plus 1 will cancel. So if you're keeping that in mind, we love that this x plus 1 is right here. We're going to simplify the bottom, and we're going to get an x plus 1. So here we go. The limit as x goes to negative 1 of 2 times x plus 3 times x plus 1 over 2 times x squared plus 3x. So I'm going to reorder that like a regular quadratic. We have x squared plus 3x plus 2. Again, I guarantee you now that this factors and it will have an x plus 1. And as you know, it does. Factors of 2 that add up to 3 are positive 2 and positive 1. So x plus 2, x plus 1 cancel. This is the limit of 2 times x plus 3 over x plus 2. Directly substitute and you'll get your answer. 2 times 2 is 4. And negative 1 plus 2 is 1. So this limit is 4. That's it.